So we know that if we're given the point at which a line crosses the y-axis and the gradient of the line, then we can find the equation of a line. So for example, if a line was to cross the y-axis at point 1 and the gradient was 2, then we could say y equals 2x plus 1. Now, before we leave the gradient, we're going to go and have a look and see how we write it down mathematically. So we've got an example here. We've got our equation of a line, y equals mx, in this case m equals 2. Now we can change this gradient m with the slider, and when we change it, it just changes the slope of our blue line. So let's put that back to 2. And we can see here that I've added in a few extra points. So this point in black on the line is the point x1, y1. And this other point in black, the line here, is going to be the point x2, y2. And we know the gradient is going to be the rise divided by the run. Now the rise in this instance here is that distance there. But that distance is just the y2 from this point minus a y1 from this point. And the run here is the distance from x2 from this point minus the x1 from this point, which just gives us this little distance. So we've got an equation here that will give us the gradient, and the equation for the gradient is going to be the rise divided by the run, which is y2 minus y1 divided by x2 minus x1. And in this instance here we can see it's going to be 2 divided by 1, and you can change this slider here and you can check and see how the gradient changes. So now we know how to find the equation of a line given the point it crosses the y-axis and the gradient. But what if we aren't given the point at which it crosses the y-axis? What if we're just given a random point on the line? So the question is, can we find the equation of a straight line given one point on the line and also the gradient? Well, we can do that, and let's go ahead and we'll see how we're going to do that now. So now we have a line here, but we don't have any x and y axis. And we're trying to work out what the equation of this line is. Now we can find a point on the line, so let's take this point here. So there's a point on the line which is 2, 8, and I've taken a note of that. So there's a point on the line is 2, 8. So the x coordinate is 2, the y coordinate is 8. We can work out the gradient of the line. Well, the gradient of the line is going to be our rise divided by our run. So in this case here, our rise, we're going from 10 to 8. So we're going 1, 2, so you can count the actual blocks, 1, 2, and our run is 1. So it's going to be 2 upon 1, which is a gradient of 2. Now we can find the equation of this line using this little equation here. Y minus b equals mx minus a. Now so in this instance here, the value of m is the gradient, and the value of our a is simply our x coordinate, and the value of our b is our y coordinate. So let's go ahead and we'll see why this works, and we'll actually go and work it out in a pen and a bit of paper, and we'll see if we can figure out what the equation of this line is using a point on the line and the gradient. So if we have a line here in blue, we can see that the gradient of that line is going to be y2 minus y1 upon x2 minus x1. Now what we can do is we could get rid of the x2 minus x1 from the bottom. We just need to multiply the top line by x2 minus x1. Now those will cancel, but if you multiply this top line by the x2 minus x1, you have to multiply the top line on the other side by x2 minus x1. So we've just done that there just now, and we're left with y2 minus y1 equals m times our x2 minus x1. So we've just done something called transposing the equation. We've taken this part of the equation over to this side. Now what we can do is we can see that we're going to have 2 points here. We're going to have our x2, y2 and x1, y1. Now what we can do is we can call our x1, y1 a particular point on the line. So that point on the line can simply be the point AB. So the value of our x1 will be a value of A, and the value of our y1 will be a value of B. So we're simply then left with this equation, y minus b equals mx minus a. So we can use this in order to find the equation of a line given a point on the line and the gradient. So the gradient is given by m and the point's given by a, b. So a is your x and b is your y. Now if you haven't seen that and it looks quite difficult, then actually doing the maths is really quite simple. So let's go ahead and see if we can solve the problem that we had from a graphical calculator. So from the graphical calculator we've seen that a point was 2, 8, and we've seen that the gradient m was equal to 2. So therefore we can say from our equation that y minus b, now the b in this instance is the 8, equals the gradient m, which is 2, times x minus, now the a will be our value of 2. So when we multiply this out, we're going to have y minus 8 is going to equal 2x minus 4. So therefore we can say that y is going to equal, and we take the minus 8 across the other side, becomes plus 8. So it's going to equal 2x plus 4. So if we've got this right, then the equation of our line will be y equals 2x plus 4. So let's go back to the graphical calculator and we'll put this in and see whether we got it right. So our solution is y equals 2x plus 4. And you can see here that our graph line sits right on top of that line there. So that is the correct answer, y equals 2x plus 4. So now we can find the equation of the line given any point on the line and the gradient.